In this circuit, oscillator circuit, we find that the some of the losses, in this case in the inductor, resistive losses are there, and radiation losses are there. Whereas in case of the capacitor, we find that the dielectric losses over here. So these total losses will be affecting on the waveform, so that for every cycle the energy is used up, and to overcome the losses, the damping of the oscillations are the same. That is, the oscillations slowly will go down, and the amplitude will gradually will decrease, and finally we will find that the waveform may go to zero, and therefore this oscillator circuit gives us the waveform as the damped oscillations. Okay, so these are not undamped oscillations. We get here damped oscillations, and the frequency of oscillation is determined by with the help of the constants of the circuit, as we have here as the L and C are the components which are to be used. So actually the frequency is determined with the help of the constants L and C, and here we are calculating this as the resonant frequency, or the natural frequency is the frequency of this oscillator, and is calculated in the form of 1 upon 2 pi under root of LC. So here from this formula we say that the frequency is inversely proportional to the components, that is L and C. As the value of C is increased, so it will take certain longer time to charge fully, and also longer time to discharge completely. Therefore, the time period will be longer one. Similarly, if we take the large value of this L also, so we will also find that the time period will be longer one. Therefore, if the longer time period will be there, it affects the frequency will be lesser. It is as it is inversely proportional. Therefore, depending upon the values of L and C, the frequency is. Tank circuit gives us undamped oscillations because of the losses of energy for every time interval. Okay, these losses are because of the resistive losses and radiation losses in the inductor circuit, whereas in the dielectric losses in the capacitor circuit, and they are because of these losses, whatever we are getting the oscillations in the tank circuit are damped oscillations. But as to operate the electronic equipments properly, we need the oscillations to be undamped one. For getting the undamped oscillations from the tank circuit, it is necessary to supply the energy to the tank circuit to meet the losses. Any energy which would be applied to the tank circuit must have the polarity conforming the existing polarity of the applied energy. Okay, at the instant of that particular application of the energy. Okay, if suppose if the applied energy to the tank circuit is in opposite polarity, so that opposes the energy in the tank circuit, so that which will cause the stoppage of the oscillations from the tank circuit. Therefore, it is must to have the undamped oscillations from the tank circuit. The energy which is supplied to the tank circuit must be proper one. It should meet the losses of the tank circuit. The second thing, the energy which is to be applied should have the frequency which is matching the frequency of the oscillations of the tank circuits. And the third thing is that phase, the energy which is applied to the tank circuit should be in phase with the oscillations of the tank circuit. If we satisfy the three conditions, that The energy which is to be applied to the tank circuit should meet the losses. It should be having the same frequency as that of the oscillations of the tank circuit. It should have the same phase as that of the oscillations of the tank circuit. So if we fulfill these three conditions, so that we will get continuous undamped oscillations from